Okay, so let's try a couple examples of writing Lewis structures. So we first have got phosphorus trichloride. Remember, the first step in writing Lewis structures is figuring out how many valence electrons total that all of the atoms will have in phosphorus trichloride. And so I would tell you at this point, that's where I would start. I would probably just pause the video and I would see if I could write the whole Lewis structure on my own at this point. You may not be able to. There are going to be some things that are, I chose a lot of these examples because they're a little bit different, so that we can see a lot of the different variabilities that we'll run into whenever we're writing Lewis structures. But I'd say pause the video right here, try to write this one on your own. Okay. So for phosphorus trichloride, what do we got? Well, phosphorus has 5. There are 3 chlorine atoms. Each of them has 7 valence electrons. 21 plus 5, 26 total valence electrons. Next, we want to pick the central atom. Central atom is usually the one that's first. It's usually the one that there's only one of. So the phosphorus is going to go in the middle. And then we're just going to put the chlorines or arrange the chlorines around. And you might say, you're doing that in such a symmetric manner. Do I have to do that? And just like I said before, it doesn't really matter. I just want to make sure that they're around that phosphorus. And then I'm going to connect each of these together with a bond. Perfect. So we've got 2, 4, 6 bonding electrons. So we're going to subtract that from the total. 6 electrons from bonds. And we've got 20 electrons left over. Next step, we're going to look at the terminal atoms, and we're going to pick a terminal atom, and we're going to make sure that it has an octet. We're going to do that by adding lone pairs of electrons to it. So this chlorine would like to have 8 valence electrons around it. It would like to have its octet. It only has 2 from the bond, so it needs 4, 6, 8. Notice how I added those in pairs. All right, we don't add single electrons, we add them in pairs. All right, this chlorine has 2 electrons. It needs 2, 4, 6 to go along with those 2 to give it 8 total. So this chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. Now, I'd say at this point, it's probably a good time to start thinking about, okay, how many electrons total do I have? I've added another 12, all right, to that compound, all right. I only have 20 total that I can add. I can't add more than that. So you got to be careful to make sure you don't add more. So this chlorine needs, it has 2, it needs 4, 6, 8. So now we have got all 3 of the chlorines with its octet. You might already jump ahead to phosphorus and say, okay, phosphorus doesn't have its octet. We're going to get to that in a second. But I would say, let's count up the total. We know how many bonding electrons we have. How many non-bonding electrons do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're going to subtract 18 electrons, and these are non-bonding. And that gives us 2 electrons left over. Whenever you have electrons left over like that, okay, sorry it was cut off. Whenever you have 2 electrons left over like that, they're always going to get dumped onto the central atom. Doesn't matter whether it has its octet or doesn't have its octet or not, those electrons always are going to end up on the central atom. And that solves a problem for us, because before, phosphorus only had the 6 bonding electrons around it. Now it has 2, 4, 6, 8. Has its octet. Everything's got its octet fulfilled here, or its duet. There are no duets in this particular compound. So we're good. All right, that's the appropriate Lewis structure for phosphorus trichloride. Let's try another one. All right, we're going to look at phosphate. All right, we're going to look at phosphate. And we're going to try to write the Lewis structure for phosphate. So if it were me, I would probably pause the video and start working. At the very minimum, try to figure out how many valence electrons there are. Now, I want you to think about that charge. What does it mean to say that we have a -3 charge on that phosphate ion? All right, that's my hint for you moving forward, trying to figure out the number of valence electrons. So for phosphate, there's a phosphorus, has 5 valence electrons, 4 oxygen atoms, each one has 6 valence electrons, that's 24. And then the charge, -3, tells us that we have 3 extra electrons. If that were +3, we would have to subtract 3 electrons. But it's -3 means something in here has gained 3 electrons at some point as it's gone through the process of forming that ion. So we have 32 total valence electrons. By now, hopefully you can try to figure out what the central atom would be. In this case, it's going to be phosphorus, and we're going to arrange the oxygen atoms around the phosphorus. Now, just because we're arranging them this way doesn't mean that this is the geometry of it. It's just the way that we've chosen to put them around that central atom. We're going to connect each one with a bond. So how many bonding electrons would that be? 2, 4, 6, 8. So -8 bonding electrons gives us 24 electrons left over. Start with the terminal atoms. It has 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. How many non-bonding electrons have we added? Let's count them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We've added another 24 non-bonding electrons. So we're done. We're done adding electrons. Double check. We made sure already that each oxygen atom had its octet. How about the phosphorus? 2, 4, 6, 8. So at this point, we would consider that a valid Lewis structure. Now, some of you that have had more chemistry might say, yeah, but there are other things that we have to consider, like things called formal charge and stuff like that. And we'll probably talk about formal charge a little bit. I don't necessarily think we're gonna cover that this week. I don't know. Maybe on Friday I'll have a video for you talking about formal charge, because you're gonna find that there are multiple ways that we can write a Lewis structure, and we need a way to determine or distinguish between which one's better than the other one. So we may well work on that on Friday. But at this point, we've gotten to where we want to be. The only thing is we have to indicate, and you might be saying, why are you writing those brackets there? You've never done that before. Well, we've not ever had an ion before. So we have to indicate that the charge would be a -3. Okay? So that would be the appropriate Lewis structure for the phosphate ion. All right? Now, one more thing to think about, and this is something that you may well have thought about already, and that is it's possible for atoms to have more than one bond in between them, more than one pair of electrons that they're sharing. We're looking now at molecular oxygen, and the compound or the Lewis structure for oxygen would look something like this. And if you look at it, it's appropriate in the sense that each oxygen does have 8 electrons around it now. 2, 4, 6, 8, because each bond represents 2 electrons. And this oxygen has 2, 4, 6, 8. And there are going to be some times where the only way that we're going to be able to get an octet is by having multiple bonds between atoms. Let's look at an example where that just might be the case. All right, and I want you might say, I have no idea how I'd figure out to do that, and I'm going to show you how to do that. So we're going to look at nitrogen. So I want you to figure out how many total valence electrons that nitrogen would have, both the nitrogen atoms together would have. All right, so just go ahead and pause it, start to do that. If you want to start further ahead, you can, and then you can come back and check your work with mine, or we'll work through it together. But I would say pause it right now. All right, so you should find nitrogen. Each one has 5 valence electrons. There are 2 of them for 10 total valence electrons. Now, a compound like nitrogen, it's, a little bit weird. There's no real central atom. There are just 2 nitrogen atoms. And then we're going to connect them together with that one bond. All right, so right now we've added bonding electrons. We've added 2 bonding electrons. That leaves us with 8 electrons to fulfill octets. So that nitrogen, let's just pick this one. It's got 2 from the bond. We're going to add 2, 4, 6, and 8. All right. That's 6 of these 8 non-bonding electrons that we have left over. So we've added 6. So we've got 2 electrons left over. They must go on the other nitrogen. All right. Now let's see. Is this an appropriate Lewis structure? That nitrogen's got 2, 4, 6, 8. That nitrogen's got 2, 4. That's a problem, okay? So we generally can't just leave electrons that don't have their octet like that, all right? We have to do something about it. So what's going to happen is, it turns out, especially whenever atoms tend to be similar like this, you'll see it. You'll see it in a number of different cases. I don't know why I'm trying to give you a general rule. There isn't. There are just some elements, and especially nonmetals, they'll share. They tend to like to share. I mean, they're already sharing electrons. They'll share more if they can. And so this nitrogen is going to say, okay, buddy, you've only got 4 electrons. You want to get to 8. I'm going to share a pair of electrons with you. And when it shares that pair of electrons, we end up with this. Notice I can't just create more electrons out of nowhere. I added those extra 2. I've got 0 left. I can't add any more. They have to come from somewhere else. We have to find some other way. And so now the nitrogen that shared has 2, 4, 6, 8 electrons. The nitrogen that was shared with now has 2, 4, 6 electrons. Okay, it's getting closer to the octet, but it's not quite there. So this nitrogen can then say, I'm going to share this lone pair of electrons with you. And now we've got what we call a triple bond between those atoms. This nitrogen has 2, 4, 6, 8 electrons about it. And this nitrogen has 2, 4, 6, 8 electrons about it. So guess what? We've gotten to our appropriate Lewis structure for nitrogen, N2. Everything has its octet. We've added the correct number of electrons, and so there we get to our appropriate Lewis structure. So you got to think about it. When you get done writing your Lewis structure, if everything doesn't have its octet, you're going to have to find ways where different elements can share electrons to get to that place. All right? Okay, so that's Lewis structures. There will be lots of problems for you to practice, so go ahead and give those a try. And then we'll look at formal charge. We'll start to think about geometry. Also, if you haven't been, check out the videos of the demos, giving you some background on some of the demo stuff that some of the demos that you have chosen or would have chosen to do for your demo project at the end of the semester. And so remember, we're still going to have like a short paper for that. I'm going to give you lots and lots of time. I hate to even call it a paper. It's just going to be mainly a report where I'm going to ask you to reflect on a couple things about those particular demonstrations. So you'll have to describe it to me, try to find one that's going to be similar to that, and describe it. So that's Lewis structures. That's sort of where we're going to be for the rest of the week.